Right. This is due to inductive effect as well as polar protic solvent. This is reversible, that is the symbol you have to write. It is a slow step. In chemical kinetics, this slow step is used to determine the rate of a reaction. It is a rate determining step. And here what is required? Polarity of the group, polar protic solvent is required like water, alcohol, etc. Polar protic solvent. Then what is formed? This bond is cleaved due to solvation of solvent. This bond is broken and we got C plus charge, 3 methyl groups. As we have to write in a trigonal planar shape, and Br minus is cleaved. So some students are failed to write plus already here. Here 1 plus is missed, or here plus is written, here plus is missed, like that. This is care to be taken. Second step is either front side or back side attack of the nucleophile. So here the nucleophile is a weak nucleophile when compared to Br minus. So therefore C plus charge, that is copying of this one, CH3, CH3, CH3. Tertiary butyl carbocation, its name sp2 hybridized carbon. It is a trigonal planar shape, and this nucleophile attacks, 2 chances are there. That is front side means CBr side previously, and back side opposite to CBr bond by viewing the reacting molecule. Then this is called either side attack of nucleophile. Yes. What is the key word you have to write, or some words? Either side attack of nucleophile is second step, which is a fast step. Here energy is released by formation of a bond, just COH, methyl group, methyl group, methyl group. Over. If you show like this, you will score 2 marks in final board examination comfortably. Then order of reactivity will be taken very soon. Here, how is SN2 reaction? SN2 reaction, we are taking methyl bromide, methyl chloride, or methyl iodide. Any one compound, halocene is changed. This is also permanently given the name. Methyl chloride is treated with aqueous NaOH. The compound is CH3OH plus NaCl. As how will be the mechanism? Here no intermediate involved. The intermediate involved in SN1 is carbocation. No intermediate involved in S. It is involved in the formation of a transition state. How is it happen? CCl bond H, H and H. This is CH3Cl. As here, where is OH minus ion attacking? As COH minus attacking backside to CCl bond. So that is a backside attack of nucleophile. Is a slow step. Then 5 bonds around carbon is possible. CCl bond is partially cleaved and the COH bond is partially formed. That is shown by dotted lines. 3 hydrogens you have to draw with thick lines. These are normal covalent bonds. This CCl bond is partially cleaved and this OH bond is also partially formed. Then this is pentavalent transition state. No intermediate involved. Pentavalent transition state. This is immediately decomposed to give. It is a fast step. So it takes place in one step. Attacking, leaving at the same time happening as that is. So therefore, COH, CH3 you have to write plus Cl minus. As how is the statement? Backside attack of OH minus ion to CX bond or CCl bond to form pentavalent transition state, which decomposes to give alcohol or methyl alcohol. This sentence carries 1 mark. This representation carries 1 mark. Total 2 marks will be provided to you. If there is a SN1 or SN2, 100% chances of asking question either SN1 or SN2. Without learning these answers, if you go means this question is not possible to answer. That is the board examination point of view, I stress you. Then come to remaining parts as comparison will be taken as practice is over. Next, order of reactivity or rate law. What is rate law in chemical kinetics? Rate law gives relation between rate of a reaction and concentration of reactants that is known as rate law. Okay, so rate here directly proportional to concentration of alkyl halide and not depend on concentration of nucleophile. This is to the power 0. No need to write this one. Just my interest. I am interested to write OH to the power something. That something is nothing but to the power 0. Next, here rate law is rate is directly proportional to concentration of alkyl halide CH3Cl and concentration of nucleophile. Both are power 1, power 1. Some of the powers in the rate law is known as order of a reaction in chemical kinetics chapter. So order is 2. What is the order in this following reaction may be asked. Order is 2. And in a single step, how many particles are participated? OH minus is one particle and CH3Cl is another species. 2 species or reacting species are participated. That is called molecularity. In each single step reaction, how many number of species participated, that number is called molecularity. Is the definition you have to learn in chemical kinetics chapter. That is 2. Both are matched, no problem at all. This is linked with the given question. The given question is SN2 mechanism, the order and molecularity respectively. 2 and 2. In SN1, the order and molecularity 1 and 1. So here order is 1, molecularity is also 1. Okay, by comparing we can identify the differences and easiness of learning is possible. That is my interest. This is the information everyone should learn and come to final board examination. After that, some other aspects will be collected very soon. What are the other aspects? Order of reactivity of alkyl halide may be asked for 1 mark in SN1 mechanism. Answer is tertiary alkyl halide greater than secondary greater than primary. What is the order of alkyl halide in SN2 mechanism? Primary greater than reverse, that is. Primary greater than secondary greater than tertiary. So in between in these two, secondary alkyl halide in the middle, what is its position? This is an alkyl halide, may follow SN2 mechanism sometimes, or sometimes elimination reaction followed, or sometimes SN1 mechanism followed. So it depends on the reactivity of secondary alkyl halide depends on reaction conditions. What are those reaction conditions will be collected here very soon. Over. So your observation is over. You practice on your own. That will help you to score in a nice manner 2 marks. Sometimes 3 marks are based on the scheme of valuation. Next step is order of reactivity. Different alkyl halides R3CX greater than R2CHX greater than RCH2X. This is general representation, nothing but tertiary greater than secondary greater than primary. Here it is RCH2X greater than R2CHX greater than R3CX. Next, different halogens, which is a living group here. Yes, that is Ri more reactive than RBr more reactive than RCl than Rn. Here also same point. So in 2 cases, 1 point is common, that is order of reactivity of iodide, halide leaving of halide. Here also Ra greater than, Rbr greater than, RCl greater than Rf. This is a common point in both the cases. After that, yes, what type of solvent is required? Here, both are polar solvents, but it is protic solvent. Protic solvent means give protons like water, like alcohol, like carboxylic acid. These are all solvents, give protons. Protic solvents. Source of protons. Polar protic solvent. Insist cleavage of CX bond and carbocation formation is favorable. Next one is solvent here as polar aprotic solvent. Polar aprotic solvent. What is example? Dimethyl sulfoxide, dimethyl formamide, etc. How will be the nature of attacking nucleophile? Yes, you are correct. Weak nucleophile is favorable here. Here, to substitute the leaving group, it is strong nucleophile is required. How will be the nature of leaving group? Nature of leaving group. In both cases, the nature of leaving group is easy to leave. Which one is easy to leave? I, Br, Cl, F. Due to longer bond distance, easy to cleave. So, I minus is a good leaving group when compared to other halogens. I greater than, Br greater than, Cl greater than, F. Yes. Nature of leaving group is good leaving group in both cases. Yes, the last point I am interested about stereochemistry. Stereochemistry of product. If you are working with optically active alkyl halides in both the cases, what will be the stereochemistry in the product? So in SN1 mechanism, due to front side attack and back side attack is inversion of configuration and front side attack is retention of configuration. Just like you are looking letter R in the mirror, that is reversal. Like that is inversion and retention. Both are happening, so that is known as, yes, both retention, many of you learned already, retention and inversion of configuration, or simply it is available as a mixture, that is racemic mixture. Yesterday I recalled racemic mixture is optically inactive. Rotation by one compound is cancelled by another compound, that is nothing but external compensation. Rotation by one compound is compensated by rotation of another compound. Which is rotation? Plane polarized light rotation by one compound cancelled by another compound. So racemic mixture is optically inactive. Here it is inversion or Walden inversion. As how will be this one? Generally RS configuration is there. R configuration, S configuration, which is not in the syllabus, but that is needed to understand Walden inversion term. Without that information, here inversion is difficult to explain by the teacher. So even though it is not in the syllabus, we have to look into that one quickly. Yesterday taken, that is a CH3 deuterium hydrogen chloride. Here it is written in this manner, easy one. hydrogen methyl group, deuterium chlorine. This is subjected to SN2 mechanism with the help of a nucleophile OH minus. Then backside to this one, what happened? Yes, CH3, H, this is D, this is OH. If you write like this, vertical line, horizontal line, we are showing the bonds around carbon atom. Around carbon atom, we are writing bonds on vertical line and horizontal line. Vertical line and horizontal line. So vertical line, the least priority group is present. So there is no change of configuration as it is. So it is number 1 group, number 2 group, 3. It is fourth one. It is number 1 group, number 2 group, number 3 group. So how is the order of most prior group to least prior group? Clockwise or anti-clockwise. So here it is in this direction from higher prior group to lower prior group. That is yes, yes. You are writing S like this. Anti-clockwise S direction. Here how is it? R, you are writing R. How do you write R? Like this. So this is R. Clockwise direction. Configuration is changing. So this is called Walden inversion. Simple example given. Take umbrella. Strong wind is blown. The outer part of the umbrella becomes inverted. In the same way, configuration of reactant is inverted in the product in SN2 mechanism. Just comfortable with turn rather than other hard work. Suppose hydrogen on vertical column over horizontal one. Hydrogen here, Cl here, deuterium here, CH3. Then what is the order? Order is what you are taken should be reversed here. Result is to be reversed here. Why? Because this is first group, second group, third group, fourth group. Fourth group is not on vertical column, vertical line. It is on horizontal line. If a horizontal line, you have to change the configuration. So at present we got 1, 2, 3. We got yes, but it is not yes. After change the groups, it is R. Automatically that one. So this is small information already discussed in your previous classes. You just follow that one. This is secondary alkyl halide. Suppose with OH minus ion in dimethyl sulfoxide, OH minus ion with water. Then here it is compound B, compound A. Formation of A follows which mechanism may be asked. It is only expected question, not like that. So R2CHX is the general formula of secondary alkyl halide. Yes, it is treated with yes, OH, same nucleophile. Nucleophile is not changed, just the solvent is changed. Here the solvent is dimethyl sulfoxide. Dimethyl sulfoxide. This is dimethyl sulfoxide is polar aprotic solvent is favorable towards. Yes, it follows SN2 mechanism. Here it follows SN1 mechanism. That is okay. It is in between. Sometimes it undergoes elimination reaction. Sometimes it undergoes elimination reaction if you are using a bulky nucleophile. What is that bulky nucleophile? CH3, C, CH3, CH3, O minus Na plus. Sodium tertiary butoxide. Alkoxide taken previously. Alcohol plus base give a salt RO minus and Na plus. This is called sodium alkoxide. This is also familiar by you. That is RONA, sodium alkoxide, is one of the reactants in Williamson's ether synthesis. So it is a base. How do we decide it is a base? Yes, it is an acid. Acid gives a residual part by donating proton is Bronsted-Lowry theory. This is RO minus. Weak acid has dashed base, conjugate base. A weak conjugate base or strong conjugate base. Reverse. A strong acid gives weak conjugate base. A weak acid gives strong conjugate base. Vice versa, you have to follow that one. So it is a strong one. So this is a nucleophile. How is the nucleophile? Bulky nucleophile, very large in size. So this nucleophile, due to bulkiness, is a strong base and subtract beta hydrogen. What is that one? We have to take like this: CHX, CH3 and CH3. If you take like this, what will happen? This base, it is secondary alkyl halide. This base subtract proton from beta carbon. This is alpha carbon from beta carbon. Automatically, this is removed, eliminated, and these sigma bond electrons converted to pi bond. So sigma bond converted to pi bond. So there is a chance to undergo elimination reaction by secondary alkyl halide in case of a bulky nucleophile. What is the bulk nucleophile? Large size nucleophile. Sodium tertiary butoxide or butoxide. Simply bulky nucleophile favors. Bulky nucleophile plus secondary alkyl halide follows. Elimination or substitution? Elimination is followed. Why? Because that bulky group is do not have sufficient space to attack. It is not permitting its bulkiness. That's why it performs a different unexpected reaction, that is elimination reaction. This is the information given in NCERT. You have to record that one. So here conditions are important in case of secondary alkyl halide. So don't bother about secondary alkyl halide. Primary alkyl halide, that is SN2 mechanism. Tertiary alkyl halide, SN1 mechanism, strictly following. But tertiary, secondary alkyl halide is in between based on different conditions. Keep in your mind that is sufficient. We will look into some nucleophilic reactions. It is given in the form of list, but I would like to write in the form of equations each one. Different nucleophilic reactions we are going to observe. So called, that is alkyl halide reacts with aqueous NaOH or aqueous KOH. That's what is the nucleophile available? OH minus ion surrounded by water molecules, hydrated by water molecules. That is attacking X minus, and we got ROH plus NaX. Reverse. Previously, alcohols are converted to alkyl halides. That was taken in the beginning of the lesson. Then this is another reaction as chemical property. Alkyl halides react with aqueous NaOH to give alcohol. So I am interested to give you CH3, CH2OH, sorry, Cl, better to write Br, with aqueous KOH with alcoholic KOH. This reaction I explained to you previously under elimination reactions. That part was over, and come to this one, compound A, compound B. What are compound A and B? A is a nucleophilic substitution reaction. We got CH3, yes, CH2OH. But here, due to dissolved in alcohol, KOH dissolved in alcohol, it is a strong base favors subtraction of beta hydrogen. Therefore, we got CH3 becomes CH2, double bond CH2. As here, as ethane is produced. This is the difference you have to identify. Here also the second case, ROH alcohol plus KX. Sometimes this is an extra information to be taken. Moist silver oxide with some moisture is taken, that is treated with alkyl halide. What will happen is not available in NCERT but possible to take as extra information. Before reacting with RX, Ag2O first reacted with moisture and formed a compound as what you are expecting. What are you expecting? AgOH is formed. AgOH is nothing but behave like NaOH, act as NaOH. Then your answer is very clear and easy. Then that is ROH is the answer. It is not possible to see by seeing Ag2O. Ag2O converted to AgOH when there is moisture. Moisture is not there, that is dry. As these two things are not in the syllabus. That is dry Ag2O, silver oxide, silver 1 oxide. That is scientific stock notation. Silver 1 oxide by showing the oxidation state of metal. In parenthesis we are writing Rx. What happened? Rx plus Ag2O, like this Ag2O plus Rx. What is removed? AgX is removed for understanding purpose. Here also AgX is removed. And what is the remaining part? R, O and R is the remaining part. And what is the unexpected product produced? ROR. Better to write in this style. Straight one, no problem. ROR is a general formula of ether. Now what is produced? Ether is produced only for extra information, not in NCERT. Why I am interested here? Moisture silver oxide gives alcohol, dry silver oxide gives ether. That difference is to be identified by you, then only possible to write the product properly. Their aqueous KOH, ROH, alcoholic KOH, elimination reaction. These differences are very, very important. Don't get confusion. Now, the well-known reaction here what I am going to give you is alkyl halide is treated with sodium alkoxide, RONA. RONA is sodium alkoxide. Sir, how is it happened or formed? Alkoxide. Sodium alkoxide. Very simple. Alcohol react with sodium metal is our next coming topic, and that gives RONA a salt. Therefore, answer is RONA, that is sodium alkoxide. Here what are removed? X and Na removed. This is performed in a dry ether. Then the product is very easy to write. What are remaining parts? R is here remaining part. RO is a remaining part. Then the product is ROR. What is ROR? Ether. This is observed by scientists like you, Williamson. So it is Williamson ether synthesis. will be studied in detail in next coming topic. Other product is NaX. How do you understand in the form of an example? CH3Cl plus C2H5ONA in the presence of dry ether. Why dry ether is required? To mix these two compounds. A solvent is required, dry ether. Moisture is not required, that is to be removed here. And then the product is plus NaCl. What is the S? I want your knowledge regarding IUPAC nomenclature of the product. Yes, methoxy. Just join your lips, that is methoxy with 2 carbon chain ethane. So its name is methoxy. 2 carbon chain is a longer chain, ethane. Yes. Common name you are familiar, ethyl, methyl, ether is the common name. So this is in next coming topic, very big information. Some exceptions we are going to take at that time as Williamson ether synthesis. Now move to a reagent like KCN, which is dissolved in ethanol, ethanolic KCN with RX. Yes. What is the nature of a nucleophile? Cn minus, already you studied, 14 electrons, 6 electrons plus 7, 13 plus 1, 14 electrons total available. Valence electrons are 4 plus 5 plus 1, positive negative charge. Total 10 valence electrons. How do you distribute between carbon and nitrogen? These 10 electrons. First 2 electrons I am trying here. Lewis dot structure of first year topic. Then 8 electrons remaining. Electronegative atoms should be satisfied by octet structure. Already 2 bonding electrons. 4, 6, 8. So by supplying 6 electrons of nitrogen atom in this cubical manner, nitrogen is satisfied with octet structure. Remaining electrons 2, 6, 2 remaining. That is on carbon, but carbon is not satisfying octets. Therefore, it is ready to share the lone pair electrons from neighboring atom, and finally Cn, already 1 bond is there. 2 pairs are shared. Then triple bond is formed. On carbon 1 electron pair, on nitrogen 1 electron pair, and this species possess 1 unit of negative charge. Cyanide ion. As what is the major product in this case? The major product in this case is R linked with C triple bond N, nitriles or cyanides. Alkyl, cyanide or alkane nitriles. This is a IUPAC name, nitrile. But this is a nucleophile capable to link through carbon as well as through nitrogen. 2 chances it has. So such nucleophile is known as ambident nucleophile. Give example is the question waiting for you. You have to answer that one. A nucleophile has 2 different linking atoms is known as. But finally 1 atom is linked, but it has 2 different linking atoms. So this Cn has carbon is the linking atom as well as nitrogen is the linking atom. Finally 1 is the linking atom. So that is known as ambident nucleophile. Same alkyl halide with silver cyanide. Here what is observed? which is dissolved in, as there is a chance of nitrogen, so RNC is also formed, and it is a alkyl isocyanate. Okay, if you observe this parallel reaction, suppose it is 80% and the second one is 20%. By considering these quantities, we are concluding that first one is major product and second one is, yes, this is major product. Concentrate on this one, no need of this one. And here, in this case, alkyl halide with silver cyanide dissolved in ethanol, alcoholic silver cyanide. What happened? As alcohol or RNC is formed in larger quantity and RCN formed in smaller quantities. So this is alkyl isocyanate is the major product. Even the reagents are looking same, KCN, AgCN, but the major products are not same. Why? The difference already given in NCERT nicely. I would like to recall, as any one of you. Very simple. What is the nature of KCN? Regarding bond, nature of bond. Nature of bond. KCN is a dash compound, like covalent, ionic. These are the two terms in your hands. KCN, K plus Cn minus ionic compound. AgCN is a covalent compound. Transition metal compound, covalent. And alkali metal compound, ionic. So, ionic compound, first one. Therefore, what is released? K plus Cn minus is released as through carbon, here carbon and alkyl group carbon. So, carbon-carbon bond is stronger than carbon-nitrogen bond. That is the reason given in this one. One reason is KCN is dash compound and AgCN is dash compound. KCN is ionic and AgCN is covalent. That is one immediate reason. Keep in your hands. As with KCN, the product CC bond formation is stronger in cyanides when compared to CN bond in isocyanates. So which bond is formed? Weaker bond or stronger bond? Stronger bond is favorable. That is another reason. And due to covalency, what happened? Silver and carbon is very busy. Therefore, RX is attacked by dash atom, either carbon atom or nitrogen atom. Why? Because halogen is ready to leave as nucleophile, and this CN part is ready to attack. Which one is possible to attack? Through nitrogen or through carbon? Through nitrogen. So over that is. What is the point? RCN is major product when RX react with KCl, whereas RNC is major product with AgCl. What is the reason? Already in the NCERT book, answer is first option is KCl is ionic compound, whereas AgCl is, while AgCl is covalent. Another one is with KCl, CC bond is stronger than, I think you recorded previously, no need of this one. The CC bond is stronger than CN bond. If there is a assertion reason type question there, Board examination, less possibility to ask, less than 50% chances to ask this question. Why? Because they want to give paper in a moderate way. Already conditions are very unfavorable, and program is not yet started in a vigorous manner. That's why moderate paper will be there. So better to thorough with all the frequently asking questions first, and then other information also to be recorded in our minds. I hope you followed this one. Now, these two are linked in this manner. CH3Br with KCN A with AgCN B as both are major products. What is the story about these two compounds? IUPAC name of A. Yes.